Here's the kit as you would receive it. All your SMD components and through-hole components, minus the DC-DC converter and the LEDs. But I have a few of them here made up. They'll be listed for sale soon. But each one will have a board on the back. A couple things to note on our instruction sheet. You will be able to print. Your components will come on a sheet that looks like this. All of your resistors for the red LEDs, green LEDs, the current limiting resistors for the transistor, or transistors I should say, orange LED resistors, 10K resistors, and these you would solder first. Your SMD capacitors second, transistors third. Well, transistors, processors, and your diode. Then we got through-hole components over here. So everything is here except the LEDs and the DC-to-DC converter. Those will not be supplied in the kit. Due to everybody having varying preferences on LEDs, you'll supply your own LEDs. Now, the colors on this component sheet will correspond with your instructions. So it will show you where to install these on the board. Your resistors are color-coded for this sheet. Your capacitors are color-coded for this sheet. And your silicon is color-coded for this sheet. So these are part of the instructions. There's a lot more to it than this. So I recommend you definitely print that off or at least read it. On your DC-to-DC converter, if you decide you want to run it off anything other than 5 volts. These are very inexpensive. On the instruction sheet, I will have more information about it, measurements, and where to get it, and that sort of thing. This was off Amazon. I don't know if this SKU would even come up as something or if it's a legitimate part number. But there'll be more information on this in the instruction sheet for sure, on how to get it and measurements so you could verify. Because sometimes they look the same and they might be a little bit different size. But usually anywhere you buy it will show you at least a diagram showing measurements on them. But these are good from about 9.5 volts to 28 volts input to run the LipLights. So if you're running it off 12 volts or the 24 volt traction pack, you'll be good to go. I want to show you a couple differences here. The old version versus the current version. So I went through a few versions of this. Revision A actually got scrapped. It had some issues. Try to get a little more light here. So the one I was selling previously was just version 1.2. Current one in the kit is version 1.2 revision B. The biggest differences here, well, one of the bigger differences that's very noticeable is the DC converter is larger. The previous one would only be good up to about 17 volts, which eliminated the possibility of running it off the 24 volt system. So bigger DC-DC converter to do that. Along with that, I added a extra capacitor. There's a couple components moved a little bit to make room for that, but that's about it. On the LED side, they look exactly the same. I did also fix some typos I had in here, but that's minor. So anyway, I'm not using these first versions anymore. We're going with revision B. Here is the assembled LipLights. Here's the original, here's revision B. In this case here, this is a 5 volt version, so it doesn't have a DC converter on it at all. But you'll notice the extra capacitor here. On this side, nothing has changed. When you receive this kit, it will have a USB flash drive in the package that will contain the STL file, so you could print these two tools. You will also receive a file to send off if you want to order a solder stencil and do it like I'm doing it here. And it will contain a PDF of the instructions. This here is actually a jig we'll show you a little later on for installing the LEDs. It helps hold the LEDs in place. while you're soldering. Also, it's nice to be able to set it in that while working on the back half. This is a must-have. This other one is just to hold the LEDs in place while you're storing it, shipping it, carrying it around, whatever. This keeps them from getting knocked on stuff. When I was selling the assembled lip lights, I would have them have a card like this holding the LEDs and have it wrapped in bubble wrap. But for the most part, I'm not going to sell any more assembled lights. I say anymore. I have a couple here I have to sell that I put together during this video. But from now on, other than these, it's probably going to be the kits. These things take a ton of time. I actually made a video and got a corrupt SD card and lost it. I spent hours doing that video and lost it, so I had to do it all over again. So to do it all over again, I had to build another kit. So I was just going to build one for the demo, but now I have two. So these are two Revision B boards complete, and I imagine I will sell both of these. We are all ready to solder our board here. I am going to use a stencil this time. I'm not very good at hand soldering SMD, so a stencil is a lifesaver in my case. I'm not going to show you how to set up the stencil necessarily. There's plenty of YouTube videos on that, but I'll give you a quick rundown of what I did. Just not a step-by-step. When you buy the stencils, it's going to come sandwiched between this board, and in my case, I got a stainless steel stencil. It's also the full size of the board. It's a big piece. I had to cut it out with scissors. And I already aligned it and did all the work to get that straight. What you would do, you would set your board in place. Have a good tight fit, so sometimes it's tricky. Now notice these other boards I have around here, they're the same thickness, and they're to raise the stencil up so it sits flat, and it helps hold the board from moving. And I fold it down, and if everything goes right, it should line up. Then I would tape it in. But essentially, you cut the stencil smaller, where it's more manageable. Tape a couple boards in place to hold your board, and then line your stencil up, and tape this top section that's like the hinge very well if you're going to reuse it many times. If you're not reusing it and you're only doing once, it's not a big deal. Just hold it in place, tape it down at the corners a little bit, and then tape it good once you're done. And if you're doing multiple boards, you just take this out, put the next one in, and go. You do need to clean the stencil a little bit in between. Okay, let me go ahead and zoom in for this part. Not sure how good this is going to show up on camera, but you'll see the basic idea of it. See if I can get close enough with it. I don't know if I can. Yeah, you can kind of see here. See how you see a silver color? It matches. If it's not lined up, now you'll see green through there. You'd essentially move these around until you line them up. So there's some key components that really have to be lined up well when you do this. If you have some small pin spacing, that's a must. You can see this processor here is definitely a fine pitch, so we want to get that right. Once you know you're lined up, it's time to tape this thing down completely so it doesn't move or shift. Double check your alignment again. It's way easier to change now if necessary. We look good in this case. This is the first time I've used this stencil. This one for my Revision B boards is a little bit different. We have an added solder jumper if we want to use 5 volts. And there's a couple of these components that moved around a little bit. Solder I'm using here. MG Chemicals. I can say I have not had much experience with different solders. This is the
this one worked really well for me. I did buy a tube. I did buy a tube of some real cheap stuff once, and it did not do very good at all. Now, they say this stuff expires. I don't see a date on this particular one, but I have had a tube in the refrigerator for a year, and I used it actually a week or two ago, and it worked fine also. So it just depends on the brand, maybe. I'm not sure. I'm sure if you keep it out of the fridge, it's an issue. What I use to squeegee this on is I use a razor blade, a brand new one each time, because it has to be perfectly flat. I've used a couple different rubber squeegees, hard rubber squeegee and plastic squeegee, and I've had issues with bridging. So far, every time I've used this, I have not had an issue. The stencil actually lifts a little bit, so you want to make sure you try to keep it down. I'm going to just put a little bit up here to work with. That's probably more than I need, but I want to make sure I cover it. Alright, so I'm going to start up here in the corner and work my way down. And maybe it'd help me if I have a little more up here. So I'm forcing it down into the hole, leaning this over as I'm doing it, but I'm also making sure that the stencil's pushed down tight against the board, so I'm not smushing it all around. And it looks like it's doing good, and I will show you what I'm doing here after I get done once I zoom in. So now we'll try the other side. Same way. Scrape up some of the excess, but sometimes you gotta be careful because you'll pull some out of the hole. That actually looks good too. So my only section I still have remaining is here around the microcontroller, and I definitely have to make sure that I don't put too much here. It needs to be level with the stencil, and the stencil can't really raise. So I'm going to start over here away from it. I'm starting on this side, and I'm going to scrape across. One time, hopefully. Sometimes I got to go two directions with it. Yeah, I might have to do it again on this one. So keep force down and make sure that the stencil's doesn't rise up off the board, or it'll put too much. I got way too much solder on here, by the way. Way more than I needed. Just get rid of some of that. Pushing hard. And that should do it. Now if you raise the stencil, as long as you're hinged right, you can go back down with it if you need to. Corner's good. These transistors are a bit picky sometimes, but they look okay. Let me pull this off and take a look. Like I said, if I need to go back down with it, it's not too big a deal. I've had to do that before, and it turns out okay most of the time. Make sure you come up straight and you don't rock this thing around. Looks really good. Instead of zooming in here, I'll bring the board closer to the camera. That might help you see it better. Grab it on the corners where I won't rub it. You can see here, there's no pads aren't touching. See if we can find a Better view of it there. Trying to get focus going. Let's see. I think you can see that pretty good. Looks like we covered all the pads. All the little transistors on the side look great. So I think we did pretty good on that. I'm going to clean this off afterwards. I'm not going to deal with it now. Now we're going to follow instructions and install some parts here. First parts we'll install, we'll start with the smallest. So we're going to go with the resistors. Remember, on the sheet they're color coded. You'd follow the board layout diagram and match the colors in the instruction sheet you get. These are, in my case, are both 100 ohm. So these would be for red LEDs and the green LEDs. Okay, bunch of them there. So we're going to go with all the reds first. Tell you what, good set of tweezers is a lot better. These are not the best. Okay, next we're going to go with some 10K resistors that seem to have all stuck to the tape. Let's see. And we have 3 10K resistors. There's 4 here, but that 4th was an extra. What our 10K resistors do, the other ones we installed were for current limiting on the LEDs. There is one down here that is actually a pull-up resistor for the reset pin on this microcontroller. And there's 2 here. Work as a voltage divider to pull the input line to 2.5 volts. The input going into the microcontroller. That is it for the resistors. Okay, first I'm going to do the 22 picofarad capacitors. And these are located on either side of the crystal oscillator. There's 3 here, but only need 2. Next up is a 0.1 UF capacitor. 0.1. So this is the smallest one here. We only need 1, but there's 2 in the pack, just in case. Now this capacitor goes in line for the audio coming into the microcontroller. This only lets AC pass through. Next we're going to go with a 1.0 UF. Do not confuse it with the 0.1. It will not work right. This is just a decoupling capacitor for the microcontroller. It is bigger, so you can tell. And I'll set it beside it here. There's a size difference. It's taller. So it would go over here. And C4. We have another large capacitor here. So this next one is a larger capacitor. This one does have a polarity. This is our first device with polarity. This line needs to match up with a line pointing away from the microcontroller. I just realized I missed a whole row of resistors. So I jumped ahead of the game and did the capacitors. I'm not going to redo this video for that, but I'll just jump on it and do them now. These are the 1.4K resistors. And what these 1.4K resistors do is they go in between the transistor and the microcontroller, and they drop the current going into the base of the microcontroller, or the base of the transistor. There's 19 of these. There's one per sequence. So yeah, it would have been ideal if I did these before the capacitors, but it really doesn't hurt in this case. Because where they're at, there's really nothing larger. The only capacitor that stands out is that one. On these 1.4K resistors, they are labeled R1 through R19, which correspond with sequence 1 through 19. So if you have a sequence issue, this is where a good place to test to see if you're getting signal out of the microcontroller going into the transistor. The transistors are also Q1 through Q19, and that designation corresponds with the sequence also, so that kind of helps there. I don't plan on adding any diagnosis info to this video. I'll probably make another one for that, but I don't know. If this one doesn't work when I'm done with it, then maybe we will. Alright, next up, transistors. As I mentioned before, these are Q1 through Q19 and correspond with the sequence. So you need 19 of these. These are just NPN transistors. Every one of them landed upside down. These are a little pickier, but they still usually pull into place pretty good, as long as you have enough solder under them. Took me months to get this board laid out. Kept trying to do it in 2 layers. Because the LEDs are in series with each other, it was a whole lot of back and forth, so I ended up having to do 4 layers. There are times where I've run into building these and the transistors themselves don't get soldered down quite right sometimes, and I would take a soldering iron with a fine tip and just push on each lead individually, and then that sequence will start working. Okay, before the processor, the last SMD component we have is a linear diode. Its job is to not allow the input voltage on the microcontroller input pin from the audio to exceed 5 volts. Otherwise, that would fry the controller. So it will work without that, but if you go above 5 volts, you have an issue. Okay, now I'm ready for the processor. Processor will come pre-programmed, so once you solder all this up and ready to go, it should work. This processor is a little tricky sometimes. There is a dot on here you'll need to line up. Okay, I locked the focus, so hopefully that stays. Now this does not like to move much when you put heat on it, I have noticed. I really need to make sure it's aligned. And the way I've done it in the past, so I would take my phone, and when I think it's aligned, take a picture of it, then zoom in and look and make sure. But under this light I can see it pretty good. I'm sure my camera's having a horrible time focusing on this. If I was a real YouTuber, maybe I would invest in that, but since this is just for fun, I don't think so. I'll go ahead and turn on my hot plate and get it preheating because we'll need it here in a minute. Meant to do that before I even set this. While the hot plate's preheating, I'll just make sure everything here is straight. Fairly straight anyway. So on my hot plate here, preheating it to about 180. It's at 132 Celsius now. Your solder should come with instructions. If it does not, there's usually a data sheet online. But this solder likes to be preheated at 180 or so, and then load around 215. Go ahead and get my hot air preheating too. On this particular hot air station, I have the smallest tip available, and I set it on the lowest fan speed. And preheating the board, it seems to work very well. Too high fan speed and it throws stuff everywhere. So I use my tablet. Took a picture of it here, see if it's aligned, and it's pretty good. It's really close. I'd have showed you longer, but I didn't want to hold that tablet over the hot plate too long. Okay, so without jarring this too much, slide it on here. Usually I have a thermal camera I will look at this board with and see if it's up to temp, but I forgot it today, so generally if it starts smoking a little, you're there. I know that's a crude way to measure it. Yeah, it goes in there. I know I'm blocking some of this, but you'll see some of them here. If I don't go straight on from the top, it blows them sideways a little bit. When I get to the end, you'll see some good. The capacitor might take a little bit to heat up. There we go. Try to get this processor evenly. Now I get to try not to drop this. It would be horrible to drop it while it's hot. Set it on this cold silicone mat. It'll cool down pretty quick. Try to anyway. Yeah, you can see pretty good there. Okay, in the previous step, we completed all the SMD work. Let's try to do another close-up video here. But everything there is in place. The SMD components are all on one side of the board. Now we're going to start with the through hole. At this point, there's a couple options. If you are going to use 5 volts to run this board, you would solder this jumper, jumper J1. Yeah, having some focus issues there, but we solder that jumper back there. If you are not going to use 5 volts and you are going to use 9 to 30 volts or so, we will need to install these DC to DC converters. One actually. This is a different design than the previous I had. And the revision A board, it used a smaller DC to DC converter that would only take up to about 17 volts reliably. This one, you could run it off your 24 volt power source if necessary. So if we're going to use this before we do anything else through hole, we will need to solder in a couple header pins for this. We are not going to mount this yet, but we want to get the header pins in place, because once we put the LEDs in place, we will not have access to solder the back of these pins any longer. So we want to solder the back of these pins now, and there's actually 2 more headers we'll install after that, and then we'll install the LEDs. So if you are going to run this off of 5 volts, skip this step and don't worry about soldering these header pins. So we need 4 of them, 4 singles. Now a couple things to note here. When we go to solder these in place, we're going to use leave these little spacers here, but we're going to take the spacers off before we actually install the DC-DC converter later on. And another thing, when you install these pins, they cannot stick up above the board on the back side. They need to be flush. So what we need to do in that case, we need to take these little spacers and slide it down a little bit. So one of the best ways I found to do that is you take another PC board. Doesn't matter as long as it has some holes in it, and it is the same thickness as the LipLight board. You put it on a hard surface, set the short end of your header pin in place, then take anything you have, essentially you could slide that plastic spacer down with. I'm pressing down firmly, and now that pin is just flush with the back side. It does not stick out at all. So that's what we want. So I'm going to do this with all 4 pins. Okay, these pins need to be installed on the SMD side of the board, not the LED side. Notice on your hole pattern here, we have 2 holes in each corner. If you look at the DC-DC converter, you can see that also. The pins are going to go on the outermost holes in all 4 corners. Now to hold them aligned, we're going to set this in place. Doesn't matter the orientation. We're not soldering it up now, so it doesn't matter if you set it correctly, as long as the 4 outer holes line up. This seems a little easier said than done. Okay, 1 more corner. To hold this in place, I'm going to cheat a little bit. I'll put a clamp over it. I'll hold it in place, make sure the pins are all straight up and down. And notice they do not protrude on the back side. They are just flush with the board. Now I'll go ahead and solder these in place. Okay, in reality there's only 2 of these that are an issue. You can see on the LED outline. This one over here and over here, not a problem anyway. So now we can remove the DC converter and it can be put to the side. I want to go ahead and shorten these pins up because they're not going to need to be that long anyway. So I will cut them pretty much flush with this little plastic spacer, and that'll set them at the right length. Okay, they're cut flush. Pop these little spacers off. Now later, when I go to install this, it will sit on here, flat against the board. That's something you might notice. In my case, I put a little bit too much solder on here. And it's probably hard to see, but it's actually raised up a little bit, and it's stopping this from seating fully. When you solder it, as long as you have a clamp on it and you press down, when you heat this pin, it's going to melt that solder and it'll go down to where it's supposed to be. But we'll just make sure it sits flat at that point. Alright, next up, we're going to install our 90-degree headers. One of these is for power and ground, and the other is for the audio signal coming in. Something to start with, you want to make sure that this plastic spacer is slid all the way to the bend, because these need to sit as low as possible to be able to clear the mounting surface of the J5 head where you bolt this to. There are two places these headers go. One is right here where it says power, and the other is where it says audio. And they face towards the back of the LipLight board. Okay, that one's in. That one's in. They pretty much sit there like this. So I'm gonna set this onto my pad here. I just want to add a little solder to one pin on each. Make sure it's angled right before I commit to it. Okay, so that one's angled down a little bit. So I want to reheat it. Get it straight. This one's a little off, so I'll do that one too. Okay, now we're right. Go ahead and finish it up. We soldered these now before we soldered the LEDs, because once the LEDs are here, you can't get to that very easy. And these stick up a little bit, but it's not a big deal. They're not in the way of anything, and almost totally hidden once you put the LEDs on. Okay, the next step, we are going to install all of the red and green LEDs. Okay, so this part can be a little tedious at times. There's a couple things that can help you out. First thing I recommend, you can do it without it, but it's easier if you print this jig to hold the LEDs in place. So this jig holds the LEDs in place while you solder them. But also, it's kind of handy if you set the board on it upside down and start a couple screws just to center it. Do both the rears, doesn't matter, as long as two are in here it'll be straight. Now you can set this down and set your LEDs in place, and the long leads poking through will just come out of these holes here. One thing I do need to note, where this DC to DC converter is, these LED leads cannot protrude through the back. They actually have to be just a tad under in length, so there's no rise at all, and we'll talk about that and show it to you in a minute. So I'm going to put in all the others except for the ones in this section, and then we'll trim those. I'll speed this part up in a second because it'll be really boring otherwise. But insert the LED in your 6mm spacer, and the long leg is opposite the flat spot, right? And if you look here, you see the flat spot on this side facing me. So on all of these LEDs, the long leg actually faces the inside of the lip light because it's reversed on the back side. All those LEDs are in. I'm going to hold off on these 8 for right now, and we're going to go ahead and solder these in place. Now the easiest way I found to do that is with this jig. I've done it one at a time, and it's not fun. Okay, so put this jig on top of the LED. Sometimes it's a trick to get all of these to line up. But if you lean it, I don't know if you'll be able to see, they all angle the same direction. Alright, if you put it straight up and down, they're some will go to the right, some will go to the left, but if you lean it a little bit, it'll all kind of go to the same direction. That makes it a little easier. I don't think I can catch all this on camera here very well, but kind of wiggle and jiggle and until they start to seat. So I have one side completely in, but the other side's not in at all. My green LEDs have pretty short legs, so I'm worried about them sliding all the way out. There we go. Okay. They're flush. Both sides all the way around. Now we're going to use 4 2mm screws. Length isn't super important as long as it is long enough to go through the circuit board and screw into the jig. When you're tightening these down, if you tighten these screws too much, it will actually lift up this corner and leave a bigger gap here. So the way you could tell if it's too tight, if you can move these outer LEDs in and out. So loosen it a little. Yeah, a lot better. This one we still have a pretty good gap between the head and the board, so I go till it just touches. A little more. Alright. The rears, because they're in between 4 LEDs in the middle there, it's over tightening it does cause issues, but it's harder to get it to work. So it's pretty easy, but generally you don't want it too tight either way. Just enough to hold stuff in place. Alright, so now we can solder all these and they will not fall out or cause issues. What is the easiest to do and less stress on the board is to go ahead and trim the leads now before you solder. Getting these long leads out of the way helps you actually get to them with a soldering iron, but trimming leads after the board's soldered, if you're trimming close to the solder, and especially if you're cutting into the solder, that can stress the board and pull up some of the pads. So cut them to the right height. And height isn't super critical here, but if you know how to solder, well, if you're doing this kit, hopefully you know how to solder. You know about where you need to be. So they're all cut off, trimmed to length, and now it will be much easier to solder. By the way, I am currently using this super El Cheapo soldering iron. This is kind of my backup. My good soldering iron I dropped fell off my workbench and actually broke the element on it, so I need to order some parts. I'm using this one. It seems to be pretty decent for what it is. I did actually make a decent tip fit in it. It's not a chisel tip like I like, but it works okay for this. Okay, I don't think I missed any. This is how you find out. Take a screw out. If they fall out, you must have missed it. Okay, they're all soldered in. All the same height. Fully seated. Perfectly aligned. This thing is a lifesaver.
Next step, we need to install these LEDs. Now, if you are going to run this off of 5 volts and you do not plan on installing a converter to run it off of 12 or 24, then there is no need to do anything special here. You just put the LEDs in just like you did the others. But if we're going to use this, the LEDs cannot poke up past the circuit board. So we need to trim the leads until they're just below the surface and then fill the joints with solder. So to do this, we're going to need to take a little bit off the leads. It takes a little bit of practice to get the right amount. I'm using my micrometer at the moment, and should be something like this. Now, I'll get another board to show you what it should look like. Okay, so I can actually still feel those a little bit. So they're poking up a tad too tall. They need to be just below the surface. And that one looks good. Just below the surface there. Hopefully that's focusing in okay. So I'm going to go ahead and trim them all that size. Okay, because these are so short, there is no real way to line them all up and get them to stand and then install the jig, so we'll do these one at a time. The inside row is green, so we'll start with that. Now there is no longer a long leg and short leg, so we need to look at this and see where the flat spot's located, and on this case the flat spot is on this side. So I will have it oriented to where that matches. Okay. And we're there, just below the surface, like we're supposed to be. And I forgot to turn the soldering iron on, so now it's got to warm up. Actually forgot to hit record. I put one more in place to solder. I soldered this one, and I placed another one here that I want to solder in place. Want to make sure we get plenty of solder in there, or it goes down into the gap between the pad and the leads. In a minute, I'm going to show you how to level off this solder where it doesn't stick up. Let's get them all on there first. So now, what we need to do here, there's no pins raised in these sections, but we have mounds of solder here that need to actually get pressed flat. So there's a couple ways to do that. One way I've done it in the past is just wet my finger, heat it up, and tap it. I've used a wet sponge to do the same thing. Alright, I don't recommend you use your finger and burn yourself. Alright. Clean some of that off here and show you what we did and what it looks like. Get a little bit of alcohol on there. Now this one, it's pretty flat. It's about the same height as the board. So we'll try that with the other one here next to it. Actually, I just pushed all the solder out of that. You can see these two are, that one's flat, that one's not quite flat yet, but these two are flat. So all of these LEDs that are underneath this power supply now are level, and the power supply will fit flush. Now we will put some Tapcon tape over these. We'll actually use 2 layers of it. Next up, we have our orange LEDs in the front. We should have 14 of these. Now these need to be bent at 90 degrees, and there's 2 different ones. So actually, let me go ahead and bend 2 of them to show you the difference. Okay. So if you notice, these LEDs on this side, the flat is on my right. LEDs on this side, flat's on my left. So we need to bend these LED legs 2 different directions. So if you look at this, the short leg's on one end, or one side. This other LED, the short leg, is on that side. So we need 7 each of these. 7 of each. These are such tight bends that if you accidentally bend one wrong, I don't think you can go back the other way without breaking the leads off. Okay, so the long leg goes on the opposite side of the flat, right? So we'll go there. Okay, have them all in place. Now we'll get the jig again. I put a piece of foam rubber here. It's actually a strip of insulating tape for like a door. So we install this down. That piece of foam holds these in place. Get them reasonably close. Now it helps put a flat surface up against the front to make them all even. Now what I'm going to do is I'm going to solder one leg on each LED and then take it off and reposition it and make sure everything's right before I do the second one. So at this point, you can see a couple of them are a little crooked here. I want to make sure they're all equally spaced. They're all straight. So first I'll start off with straightening them. Sometimes once I do that, it fixes the equal space issue. Those look pretty good. Now we only have a few components left. We have a potentiometer, 2 capacitors, and the oscillator. We'll do the capacitors first. There is 2 capacitors that go in the back here. On these particular capacitors, let me show you the footprint here. It's pretty hard to see, actually. Let's see if this actually focuses. I think it's focused there. You have your symbol here. You got C4 or C5 and C6. Now the positive is the unshaded area, and there is a little plus sign there, but it's real hard to see. But the positive for both of these face each other. The positive faces the inside of the board on both. And there we go. Those 2 are in. So next up we'll have the oscillator and the potentiometer. So our crystal oscillator here, it installs on the LED side. If we install it on this side, it will not clear. It'll be too tall. The excess leads off. And now we have the potentiometer for adjusting the input gain. Okay. That is it. Now it is time for the DC to DC converter. Very important step to do before you do this, before you install this part. We need to adjust this to 5 volts. If we just install it, we'll destroy this board. It will definitely kill the microcontroller and possibly the linear diode. I actually did this the other day. I put 12 volts on a board that was meant for 5 volts, and it only took a split second to start popping and destroy this. It actually pops a hole in it on one corner every time, and I say every time because I have done that more than once, unfortunately. Somehow I misplaced my wide roll of Kapton tape. So we use some multiple skinny strips here. Let's see what happens. So one of the easier ways I've found to do this you can let it hang over the end because we're going to trim it off with a razor blade afterwards. That's better. Now we do need to expose these solder pads. we taped it up and exposed the 4 solder pads. Now, I'm going to put it back on this. It's handy to hold it still. Okay. So there's a couple more places I want to put tape just to double up. The back side of this converter is ground plane. And if either of these LEDs rub through, it's either going to turn them on all the time or short the power. Neither of which we want. Alright, so we got 2 layers. We got a layer across this entire board on the DC converter. And then we have a layer over all of the LED pads. Now, once again, if you're going to use 5 volts to run this thing and not the DC to DC converter, then there is no reason to even bother with this. Now we do need to make sure this is set to 5 volts first. It's off screen here, but I have a power supply. And I've got input on this side. And there's an arrow, input and output. This is in positive, in negative, out positive, out negative. These are both marked. So I am going to add negative input and positive input. Now I need to get the DVOM. Okay. I turn my power supply on. I'll put it at about 12 volts. I'll go ahead and put it 18 or so. So we're putting 18 volts into this, getting 10 out. Now I'm going to adjust this potentiometer on the DC converter. If you turn it to the right, voltage drops. Left, the voltage rises. So we want it to be about 5 volts. I'm actually going to go a tad below 5 volts. We'll go right to it just to see what it does here. So there's 5 volts. Now I've noticed when I put this under load, it does change it a little bit, so I might have to readjust once we mount it. Now ideally I would put a resistor across here to load it, or even a couple of LEDs maybe. And that might give me a true reading. But it's really close at this point, so we're going to go with it. We definitely won't fry our board now if we hook it up. So installing this, the arrow is our power flow. We're flowing power that way. This is the input side. This is the output side. And they are marked on the board. But if you look, we got out positive, out negative, in positive, in negative. Also, a warning here. Adjust 5 volts before install. So that's a reminder to do what we just did. Okay, so this should mount down on the pins we installed earlier, like so. Then we'll add a little solder. So I'm pressing this down flat and reheating all the pads just to make sure it goes down flat. And if we look at it here, we can see it's definitely pretty flat. Now, looking at that side, there's a little bit of a gap there, so we'll push this side down a little bit more. Okay, that's good. Alright, that is it. It is completely assembled. Now it's time to power it up and see if it does anything. So there's a couple ways to do this. Originally I had a little adapter where I'd put a 9-volt battery on these to power them, but not the 5-volt version. But now what I do is I use my power supply, because my power supply I can monitor current. And if I see the current's up too high, I'll shut it off right away before I burn something up. Something could be wrong with the DC-DC converter or a short somewhere. So positive is always this side. Negative is on the inside of the board. Alright, let's see if there's any magic smoke. We're at 15 volts going in and we are drawing 0 amps at the moment. Okay. Now, go ahead and power it off so don't short anything out moving it around. So there is a test mode on here. So once you build it, you need to light up all the LEDs, make sure they all work, all the sequences work. And what the test mode is, you have 3 test points here. You have 5 volts, ground, and signal going in, audio signal. If you short the signal to 5 volts while you power this board up, it will enter a test mode and light up all the LEDs. Now, if you have audio connected to this, it will not affect it because this is on the microcontroller input side. It is past all the filtering, so you're not putting 5 volts back into your amplifier. This will just turn this board on. So we're going to set it down, and I'm going to cross my fingers here. I'll just short it with these tweezers. Power it up. Hey, it's doing something. Alright, we do have one LED is not lighting. Alright, so one LED. That's going to mean that LED is in backwards, it's bad, or the resistor going to it. Because on our green we have a resistor per LED. Because it's not both of them, I know it's not a total sequence that's going bad. Actually, let me let it sit. One more thing this test mode does is it will tell you the firmware version. So this will light for 30 seconds or so, and it's going to flash 1, and that's 4, so 1.4. So 1, 2, 3, 4, 5, 6. 6 LEDs in. You know what? I sure hope I didn't put that LED in backwards. With it being underneath that power supply on the edge, that makes it a pain. So the resistor for that LED is this one here. So I'm going to hit that with some heat. Let me shut off power so I don't short anything. Make sure that resistor is soldered properly. Okay, got that side. So always hold it down with your tweezers. Otherwise, you probably just flick it off the board. Let's try this again. There we go. That's all it was that resistor. So they all light up. It's working so far. Now we're going to test it with audio input. So to test audio input, I have this cable I put together for that. I've never done this with my tablet before. Usually I use my PC, but I'll just have a Johnny 5 soundboard on here with audio coming out of this tablet going into it. And I have a splitter with some headphones with some earbuds I can hold up to the mic so you can hear it too. Let's see. So in audio, in this case, since it's isolated, it doesn't matter which negative and positive. But when you install this on a robot, you're going to need to make sure it's right. Negative is on the outside of the board, positive is on the inside for the audio input signal. Alright, we need to turn our gain up here. This tablet probably is not going to put out enough power to light all 19. But you can see it's working. For my test here, I know the LEDs work because I ran them through the sequence. And this is enough to tell me the audio input stage works. Alright, so that was a successful build. Those are done. And that fits to keep the LEDs aligned. Keeps anything from working its way loose while you're storing it, shipping it, or whatever. There's something I just realized I forgot to do at the end of my last section of video, so I'll just add this to it. Remember how we set this power supply to 5 volts before we installed it. Now, sometimes under load, these drift a little bit. It won't be much. It'll probably be by 1/10 of a volt. Maybe 2/10, but very rarely. These larger ones, I haven't had that issue. So what we have to do is power this up and see where it's at now. So what we are going to do, I have a test point on here. I'll show you this other board real quick. Let's see, where is it? That's the wrong side. There we go. So we got, let's put it where it's not upside down. Signal, ground, and 5 volts. So we're going to test at this 5 volts, which is towards the outside of the board. The one towards the center of the board is signal. And if I had the board flipped over, down here it'll be signal, ground, and 5 volts. And that's where we're going to be checking. So instead of actually grounding on that pin, if I had 2 leads like this, I could do it, but I have this hook on here, and I'm just going to ground on the power supply input because it is identical anyway. Let's see where we're at right now. So I just powered it up. We are supplying 12.2 volts, getting 4.983, which is pretty close. Okay, now we need to light up all the LEDs. So I'll power it back off. Short the signal to the 5 volts. Then power it back on. We'll run through a sequence. Then all the LEDs will light. Now we'll check our voltage. 4.912. So not quite 5, but close, but we could fix that. You have 30 seconds to do this before the lights go out, but you could always reset it. Now to go up, I'm going to go counterclockwise a tad. It's very tricky here. You can easily turn too much. All right, I'm at 5.1 right now, but my LEDs went out. See where we're at. Well, get the LEDs back on. Under load 5.03. Yeah, with this potentiometer, it's really hard to get any closer than that. Okay, so I'm a tad under. With no load, it's at 5.019. With load, we're at 4.946. 50 millivolts off, 55 millivolts off, which is nothing. So now I have 12 volts going into this. I'm going to bump it up to 24, 26, somewhere in there, just to see. All right. We're at 27, and we're at 5.009. So there's a happy medium. We're 55 milliamps, or 55 millivolts down with a 12 volt input, but right on the money if we're running it off the traction pack. So depending on how you're going to run this, if you're going to power this off of 12 volts, adjust it to be a true 5 at 12 volts. If you're running it at 24, adjust it there. But either way, this slight fluctuation won't matter. Just for fun, let's see how much current this thing draws. So we're going to change the way things are set here. Alright, so now I have my meter in line with this. We'll power it up with no load. And we have I'll set it to about a 26 volt input. 26 volt input, no load. We're drawing 3 milliamps. Get everything lit up. Okay, full load at 26 volts. We're looking at 248 milliamps. It's not much there, really. So I'm going to drop it down to 12 volts. Should see this go up. Hopefully don't go above the meter's range and blow my fuse. There's our meter range at 400. That's at 15 volts. See if it'll go higher. My LED's timed out. Alright, so I'm putting it on 12 volts. We're right at 12 volts now. We'll cycle power, get all the LEDs lit, and see what happens. $480. So about 480 milliamps at 12 volts. Right about half of that at 26, 24 volts or so. So not too bad. And that is with all LEDs on all the time. With this board actually working, it's going to draw less than that. And when it does draw this, it'll be for very short periods of time. 6 milliamps rest. With 12 volts, approximately half that when you double the voltage, which makes sense. Give you a little bit of info here on how I program our microcontroller. So we program this ahead of time, and the part you receive in the kit is already programmed, and once you put the kit together, it'll work. But we got our error OK and program lights,
We have LEDs here for each sequence. There's 19 sequences in the LipLights, so I have 19 LEDs. Have an audio input. Basically, the circuitry in this is exactly the same as the LipLights. To look under it, got some resistors for the LEDs. The only thing this is missing is it does not have the transistors that the LipLights have. But for running one LED off the pin, we don't really need it. Okay, this orange dot matches the dot on the microcontroller. So what I do when I start here, alright, I remove the controller. So the dots on this corner, I have to make sure this will match when I install it. Set it in place, double check. Yes, the dot matches. I also have a mark here to make sure I insert this properly. So we're installed. First thing we have to do is burn the bootloader. Okay, bootloader's burned. Now we're going to install firmware version 1.4. And that's it. This is now LipLights. So now I want to test them. So each one of these I program, I run it through this test first before totally being convinced it's programmed. Alright, so we'll put some audio in from the PC here. Hitting some of them there. We're actually turned a little too high. Turn down the gain a little bit. Alright, so this is basically it. Each one will go through this stage. So we'll get programmed. Once programmed and verified it is actually working, alright, the software version on it, in this case 1.4. 1.4 is my kit software, which has a couple different features than the other one. One is a test feature, where once you build the kit, you short two pins together while you power it, and it lights all the LEDs so you can test them and make sure everything's working. So at this point, it goes back in the package it came in. All the pins remain straight, in good shape, and there is a 1.4 written on top. So as long as you see that on there, it has been through this test. At the end of this video, I wanted to put together a quick sneak peek of things to come. Alright, let's power it up. Flip the switch, you got a couple boot screens. And there's a password, so if you leave this sitting, nobody can take control of it and destroy your robot or themselves. If you need to change this password, which is default in the beginning is going to be all zeros, hit the bottom left corner, top right corner, and right here. And it goes into a mode where you can set your pin number. We'll set 1, 2, 3, 4. Hit save, reboots. Now 1, 2, 3, 4 should work. Okay, there's kind of our main menu at the moment. once again, all this could change for sure. This is definitely in the prototyping stages. At any point during the control, we can go back and hit lock, and it'll go straight to the lock screen. Got manual control, sequence select, manual control with sequences, a soundboard. All of these aren't programmed in to do anything yet. A bunch of placeholders, but like I have it go to the 404 screen just to show that button's working. At the moment, let's see, we got manual control kind of laid out. So these are the 3 icons I've created so far, and this thing is totally up in the air. It doesn't necessarily designate this particular joystick to do anything. You get to designate that. So right now I got the track drive. If we click, I'm sorry, here I clicked it wrong. You gotta click your joystick first, and then select what function you want. If I want the track drive to be the left joystick, I'll tap it next. So in this mode, the X and Y axis are going to control the tracks. And if you look a little closer here, you'll see some blue arrows. Those blue arrows are the sliders. So one slider is going to control the actuator and the torso, and the other slider is going to control tiptoe in this case. So if we want the other joystick to do something, we will tap it, and we'll say it controls the neck. And this one, your joystick left and right will cause the head to lean, up and down will nod, and twisting the Z axis will rotate the neck. And if you look closer, you'll see some blue arrows here. One of these will control the vents, and the other one will control the iris, and all that can be changed. But once you select your modes, you hit enter, and it's ready to control the robot. So this warning is just telling you basically Johnny is alive. If you touch his stick, he's going to move. Once again, joystick functions are in red, slider functions are in blue. And at any point, I could hit lock and go back to the lock screen and everything shuts down. Or hit menu and it shuts down. But it doesn't matter which one of these you select. We can select, this for the left, that for the right, hit enter, and it's going to go to controlling it. Hopefully one day. So from here, if we go back, another thing I was working on recently is in setup, we'll have LCD brightness and control tests. Today I was tinkering with control tests. So here we can check our controls, make sure they're at least working. This tells us they're connected to the Arduino and working, and we have a serial connection to the LCD. It doesn't test anything on the robot yet. Our sliders over here, we can test those too. Z axis I'm working on. It's a little glitchy, but it's supposed to rotate this gauge. And the same thing on this side. So from here we back out, and if we want to lock it, hit lock. Now nobody can do anything without a PIN number.
Speech and soundboard. This is actually working now. This is actually working on my demo parts, but you would tap the soundboard, and this could be multiple pages. Right now it's just one as an example, but this would just make the soundboard work on the robot.